So we're going to solve some problems involving rational exponents. Now remember, a rational exponent is something that's an exponent, so we have x to a power that is rational. In other words, it's a fraction. So x to the 1/2. Remember, x to the 1/2, you should think to yourself, square root of x. That's what x to the 1/2 thinks. So if you have the square root of x equals 2, you'd say, what number square rooted is 2? So what you'd come up with there is x equals 4, right? Now, if you wanted to, what you could do here is you could think about squaring both sides, right? So square both sides. 2 squared is 4. 1/2 times, remember, if you have an exponent to an exponent power, you multiply. 1/2 times 2 is 1. And so you can sort of see we have x to the 1 equals 4. Now, some caution there, okay? Because what if you had x to the 1/2 equals -2? Well, you might say, I know how to square -2. X equals 4. Well, if you put this to the test, if you sort of put this back into here, you'd say, hey, the square root of 4 is 2. This works fine. But if you took this and put it back into the equation, you would get a big fat no. So this doesn't work because for even denominators don't actually allow for negative outputs, okay? Now, odd denominators indicate something like a cube root or a fifth root, and that's just fine. So let's think about x to the 1/3 equals 2. Okay, so what should you be thinking here? Hopefully you're thinking to yourself, this is like the third root of x. Now, what's the third root of x mean? It means this is the thing that when multiplied times itself 3 times equals x, right? So third root of x times third root of x times third root of x equals x, just like the square root times the square root equals x. Okay, so we've got this. Now we can use sort of that same technique here. We can raise that to the third power, that to the third power, and lo and behold, these cancel and we get x equals 8. And you could come back to the original equation. You could say, what's the cube root of 8? Well, it's 2. Woohoo! It works. Okay? Now, nice thing about the cube root, because that's odd, you can make it equal to -2, and you'll still get a solution. Why is that? Because now, if you raise that to the third power, what'll happen is the third power, that odd power, doesn't annihilate the negative, so we get x equals -8. -8, if you take the third root of that, is in fact -2. -2 times -2 times -2 is -8. Now, so you can see in this case, you have one that has a solution, one that doesn't. In the odd root, you see that both have solutions. And you can put these into other problems that have other pieces. So let's say you have x minus 1 to the 3/4 equals 27. Okay. Let's make sure that I like that problem. So what happens here is I'm going to say, well, I'd really like to get x by itself. Okay. So I'll go ahead and do my work in red again. I'd really like to undo the 3/4 power. Well, how do you undo the 3/4 power? How about raise it to the 4/3? 4/3. Now, here I've got this fractional power here. I can actually decompose that fractional power. So 27 to the 4/3 is the same as 27 to the 1/3 raised to the 4th, right? Because 1/3 times 4 is this. Why is that handy? Well, I know what the 1/3 power of 27 is. What's the cube root of 27? The cube root of 27 is 3. So really what I have here, those cancel. I have x minus 1 equals 3 to the 4th. And 3 to the 4th, if you think about that, you could maybe do this off to the side. That's 3 times 3 times 3 times 3. By associativity, probably what most of us would do is 9 times 9. You can multiply in any order. And so 9 times 9 is 81. So we get x minus 1 equals 81. Add 1 to both sides. 82. Okay. Then, of course, good problem-solving strategy. Just like we talked about these, you ought to check just to make sure this makes sense. Okay, so I have 82 minus 1 to the 3/4 power. So let's see, that's 81 to the 3/4. What's the 4th root of 81? Well, you could punch it into a calculator or say, hey, what times itself 4 times is 81? That is 3. And so we have 3 to the 3rd, and 3 to the 3rd is indeed 27. And so it checks. And that's the solution here. Now, because that is an even 4, let's see what happens if we put a negative on the other side. So x minus 1 to the 3/4. This is a new problem, right? Solve the last one, so let's give ourselves another one. What happens here if we use the same technique? Well, hopefully you're taking this and you're trying to generalize yourself. That's good problem-solving strategy. In fact, you might even pause the video and say, what's going to happen here? Well, let's sort of investigate. 4/3. Okay, so they're going to cancel over here. Here, remember, negative 27 to the 1/3 to the 4th. Okay, negative 27 to the 1/3 is negative 3 to the 4th power, x minus 1. Okay, so then we get x minus 1 equals negative 3 to the 4th, that's 81. Add 1 to both sides, x equals 82. Ah, that's great, we got a solution. Whoop-a-dee-doo. Only problem is, it doesn't work. It doesn't actually solve the original equation, right? So if you were to check, what would you do? You'd put in 82 minus 1 to the 3/4. That's 81 to the 3/4. The 4th root of 81 is 3, so 3 to the 3rd equals 27. Not negative 27. Well, so this is not a solution, and there is no real solution to this. Now, we could have predicted that because we had an even term in our denominator, and this is a negative. But we can also check it, and we can see that's the correct solution.